All right, let's just jump straight into this explainer because today is all about one thing: building your coding confidence. If you've ever felt that pit in your stomach right before compiling, just dreading that your code is going to instantly break, well, you are in exactly the right place. Today, we're tackling constructors. We're going to completely demystify how objects are actually born so we can finally banish those annoying null pointer exceptions for good and get your code working flawlessly from moment zero.
So picture this. You walk into a tech store, right? You're pumped. You ask for their absolute latest, top-of-the-line smartphone, hand over your card, and they hand you this pristine, shiny glass brick. But you go to hit the power button, and literally nothing happens. It's totally dead. You press it again, and still nothing.
So you complain to the clerk, but instead of helping, they just laugh at you. They're like, well, obviously it won't turn on. Calling a new phone just allocated the raw memory space. You never told us which OS to load. I mean, it sounds totally ridiculous in the real world, but honestly, this is exactly what happens in Java if you aren't paying attention. Your object is fundamentally broken right out of the gate because you didn't tell the factory how to set it up.
And that right there is exactly why we need constructors. You can think of them as your code's ultimate quality control on the assembly line. It's this strict mechanism that literally forces the factory, which is your computer's memory, to run an initial setup before handing the object over to you or anyone else using your code. No more empty shells. It absolutely guarantees the OS is installed before that phone ever leaves the factory floor.
Okay, so let's look at our first major hurdle. We call this the hidden implicit trap.
Here's the deal. If you build a class and don't write a constructor yourself, Java tries to be helpful. It swoops in and secretly inserts an implicit default constructor. It's completely invisible in your code, it takes 0 arguments, and it essentially just guesses what your value should be. Numbers, it sets them to 0. Text, sets it to null. It just leaves you with completely empty, hollow data. To see why this is such a massive issue, imagine a teammate writes a rocket class but totally forgets the constructor. You come along in your code, you innocently call new rocket, and boom. Because of that sneaky implicit constructor, your rocket just launched with a null destination and exactly 0 fuel. I mean, that is a guaranteed crash. Relying on this implicit default when you're using someone else's class is basically a one-way ticket to failure.
So, to build real coding confidence, we need to transition to a safe setup with parameters. We've got to stop relying on invisible compiler magic and take back control.
And we do that with parameterized constructors. This is where you put your foot down and confidently enforce the rules. You force anyone making your object to hand over the necessary data up front. If someone wants to build a rocket using your class, fine, but they have to give you the exact destination and the exact fuel levels before that rocket even exists. You set up those variables safely, well before the object is ever used.
But hey, a quick warning here. Taking control like this triggers an ironclad compiler law, and it trips up almost every beginner.
It's the golden rule of default constructors. The very second you write any custom constructor, Java permanently revokes its hidden implicit one. That invisible safety net? Poof, it's gone. Which means if an outside caller tries writing new rocket with empty parentheses, the compiler's going to instantly block them with an error. Java demands those parameters now. But what if you actually want both? Let's talk about explicit default flexibility. How do we offer a strict custom setup, but also an easy, safe default?
Simple. We write an explicit default constructor. You manually type this out right alongside your parameterized one. It takes no arguments, just like the hidden one used to. But instead of leaving things at 0 or null, you dictate the safe preset values. Maybe you default the destination to Mars and the fuel to 500. Now, both an empty call and a highly specific custom call work perfectly. And more importantly, they are both completely safe.
Let's break this down with a quick food analogy. Relying on that invisible implicit default is basically like a kitchen handing you an empty plate with invisible food on it. The second you try to take a bite, your code crashes with a null pointer exception. But compare that to the parameterized constructor. That's your custom order. You're telling the kitchen exactly what ingredients you want, like beef and cheddar, before they even fire up the grill.
And our explicit default constructor? That is your menu's classic burger preset. You don't need to specify a single topping because the kitchen already knows exactly what makes a classic burger. You get a complete, delicious, entirely safe meal right from moment 0. No invisible food, no crashes, just a rock-solid, reliable preset.
All right, let's put you in total control now. Let's practice and really lock in this coding confidence.
We're going to do a user class challenge. Just 2 fields,
a string for the name, and an int for the age. Your mission is to use both types of constructors we just talked about. Task 1, add an explicit default constructor. And Task 2, add a parameterized constructor for those custom inputs.
Here is exactly how we execute this safely. Step 1, you write out your explicit default constructor, 0 parameters, and you safely set the name to guest and the age to 18. Easy. Step 2, write the parameterized constructor that takes in a custom name and age. And Step 3, this is where your confidence really shines, you add some safety logic. If someone tries to pass in a negative age, you catch it right there in the constructor and safely override it to 18. Boom! Your object is completely protected before it ever leaves the factory.
Look at how much ground we've covered here. You have officially graduated from being at the mercy of hidden compiler rules and those mysterious null pointer exceptions. By mastering constructors, you are now the absolute boss of your code setup process. You dictate exactly how objects are born. So, as you fire up your code editor today with this newfound coding confidence, I'll leave you with this. You control the assembly line now. What kind of objects will your factory build today?